Hello students, welcome to today's class on linear equations in two variables. In the previous classes, we discussed about linear equation in one variable. To extension of that, in today's class, we are going to discuss about linear equation in two variables. So before going to that, we'll have a small recap of what is a linear equation and then we will see what is a linear equation in two variables. Right, my name is Avinash and I'm a graduate from IIT Kharagpur. Let's start today's session. The very first thing, okay, so what is a linear equation? What is a linear equation and what is a linear equation in one variable? Okay, for example, we have a term like ax plus b equal to 0. If we have equal to, it is an equation. And what do you mean by linear? Linear means x power 1. Okay, if I have ax plus by plus c equal to 0, is this a linear equation? Yes. Why? X power 1, y power 1, both the variables are having the power 1, which we actually say degree. We already discussed in the previous class what is the degree, right? So degree of this equation is 1. The power of x, power of y is 1. But here how many variables are there? Only one variable. But here we have two variables. Still it is a linear equation. Okay, I'll write one more. Ax plus by plus cz plus d equal to 0. It is still a linear equation with the three variables. So what is the concept we are going to discuss? A linear equation in two variables. So first of all, tell me what is a linear equation one variable which looks like ax plus b equal to 0. Okay, so this is with only one variable. This with two variables. This with three variables. These are linear equations. Linear means power 1. Linear means power 1. Now the point is, we are going to find linear equation two variables. All this we have discussed in the previous classes, right? In your lower classes, if we have an equation like 2x plus 6 equal to 0, 2x plus 6 equal to 0, you said 2x equal to minus 6 and x is equal to minus 6 by 2. So x is equal to minus 3. X is equal to minus 3. So this is how we solved a linear equation in one variable. So in today's class, let us try to understand about linear equation two variables. And in the coming classes, we will try to discuss how to solve or how to find the solution of a linear equation in two variables. Right? The first one we're going to discuss is equation of the form ax plus by plus c equal to 0. Ax plus by plus c equal to 0. This is the linear equation in how many variables? Variable x is a variable, y is a variable, c is not a variable. A is not a variable, B is not a variable, C is not a variable. These are constants, these are numbers. These are constant numbers, that 2x plus 3y plus 4 equal to 0. That x and y are variables. X and y are variables. So any equation of this format are called linear equations in two variables, but there are small conditions. What are them? Where a, b and c are real numbers. Where a, b, c are real numbers. What are real numbers? Just numbers, right? What do you mean by real numbers? So later we'll be discussing what are real numbers and what are complex numbers. But for now, if you want to know what are real numbers, we know what are natural numbers. Extended to that, we know what are whole numbers. Extended, we know what are integers. Integers represented with z. From integers we learned what are rational numbers, q, and we also discussed along with rational numbers we also discussed irrational numbers. Let us say we represent that with t. Rational and irrational. Clubbing all these values, we say them as real numbers. Natural, whole, integers, rational, irrational, so all these are called real numbers. So where a, b, c, the values of a, b, c should be real numbers, and a and b are not both 0. or not both 0. What do you mean by not 0? That means both of them should not be equal to 0 at the same time. What will happen, you can ask me, sir, what will happen if A and B are 0? You can also see here. If this is 0 and this is 0, so these two values become 0, we are left only with the C equal to 0. We are left only with C equal to 0, which is not a linear equation first of all, which is not a linear equation, two variables, right? There is no variable here. That is the reason. Whenever we are defining a linear equation, the constant or the coefficient should not be equal to 0. Coefficient means the value before the x. Even the before case where we discuss linear equation, here also a not equal to 0, this part should remain as it is. It should not become 0, right? Same way for ax plus by plus c equal to 0, not both a and b are 0. If both are becoming 0, it is no more a linear equation. It is no more a linear equation, right? So moving ahead, where do we use this concept? Where do we use this linear equations two variables concept? Are there any practical applications? Are there any real life scenarios or real life strategies where we apply linear equations concept in that? Yes, definitely. There are many such cases. Just imagine. Okay, just imagine we are going to some bookstore and we are buying 4 pens. Okay, 4 pens and 2 books. 4 pens and 2 books. We asked the shopkeeper to give us 4 pens and 2 books, and in return he said the total cost is 100 rupees. The total cost is 100 rupees, but still you don't know. Still you don't know what is the cost of each pen and a book. By this time, you still don't know what is the cost of each pen and book. Although you know the total cost is 100, you still don't know what is the cost of pen and a book. So, to solve such type of things where you have two variables, what are the two variables? What are the two variables here? Pens and books. Pens and books are the variables whose cost is not yet known, but using some linear applications, linear equations solving in different methods, we can find the value of each pen and the notebook. Although with one single condition we cannot define them, but we'll be having two equations to solve for two variables x and y. So first of all, what we'll do, we'll try to represent this in a mathematical form. We try to represent this in a mathematical form. You can see here. Okay, so yeah, one second. So this one, to represent in mathematical form, we take pens as x, some value of x, and notebooks as some value of y. Using that x and y, we try to frame an equation. We try to frame an equation and then we'll move ahead. Okay, so let's see what is there here. So let us represent the same information in the form of linear equation. Linear equation. So said you represent pen with x. So how many pens we are buying? 4x. So 4 into x is 4x, and 2 notebooks. 2 notebooks plus 2 notebooks, 2 times of, we represent notebooks as y. So 2y is equal to 100. 4x plus 2y is equal to 100. At this point of time, if you want to find the value of x and y, that means the cost of each pen and notebook, you get different possible cases. You get different possible cases. You keep x equal 10, you'll get some value of y. You keep x equal to 15, you get some other value of y. So we get a lot of possible cases and we don't know which is correct. We don't know which value or what is the cost of each pen and notebook. So that's the reason I'm saying, just with one linear equation you have a lot of solutions, but to get the solution you need to have at least 2 equations, because we have 2 variables x and y. Okay, so moving ahead, how many solutions does it have? The same thing I'm talking about. 4x, what is the equation we discussed here? 4x plus 2y is equal to 100, correct? 4x plus 2y is equal to 100. So now, if I say each pen is 10 rupees. Each pen is 10 rupees. So 4 times of 10 plus 2y is equal to 100. So 4 into 10 is 40. 40 plus 2y is equal to 100. So 2y is equal to 100. This plus 40 will go to the other side. Minus 40. 100 minus 40. 2y is equal to 60 and y is equal to 30. So if we consider each pen as 10 rupees, we got each book as 30 rupees. So that the total cost will be 100 rupees. But if I assume each pen as 15 rupees, each pen has 15 rupees, so then we'll try to find what is the cost of each book. 4 into 15, how much is that? 60. So 60 plus 2y is equal to 100. So 2y is equal to 100 minus 60. So 2y is equal to 40 and y is equal to 40 by 2, which is a 20. So if we assumed each pen to be 15 rupees, then each book will cost 20 rupees. So which of these two are correct? Okay, I took pen as 10. The other case, pen as 15. Some other friend can take the possible value of pen as 5 rupees. You may start with taking pen as 20 rupees. So it all depends. It all depends on the value of x or y which we actually start with, correct? So how many such cases are possible? Infinite. Infinite. I start with 10. Some other person will start with 11 rupees. Some other person will start with 20 rupees 50 paisa. It is possible, right? So there are infinite cases, infinite possible solutions for a single linear equation. For a single linear equation, there are many cases, many possible cases, and all of them are correct. But the point is how to solve them. And I told you, to get unique solution or to get only one solution, you need to have at least 2 equations. If you're starting to solve, if you're trying to solve with only one equation, you have a lot of cases, right? So let's move ahead and let us try to see one question here. Okay, find 4 different solutions of the equation 4x plus y is equal to 9. First of all, tell me, is it a linear equation? Yes. Is it a linear equation 2 variables? Yes. How can you say that? X and y. X and y 2 variables, we can see it is an equation, and both x and y are with powers 1, x power 1 and y power 1. It is enough to say that it is a linear equation, and as we have 2 variables, we can say linear equation in 2 variables. Linear equation in 2 variables. Now the point is, when I start with 4x plus y is equal to 9, let me take x is equal to 1. X, let us say, let the value of x is equal to 1. So 4 times of 1 plus y is equal to 9. 4 plus y is equal to 9. Y is equal to 9. This plus 4 will be transferred, becomes minus 4, which will give you y is equal to 5. So one solution of x and y is 1, 5. We represent that in brackets, ordered pair, we say. Okay, the first one is x value and the next one is y value. So 1, 5 is one solution. The question is 4 different solutions. So I start with x equal to 1. You start with x equal to 2. You start with x equal to. Ask your friend to start with x equal to 3. One more person who is more creative can also start with x equal to 0. X equal to minus 1, x equal to minus 2. There are a lot of cases there. Right? What happens if we keep x equal to 0? If we take x equal to 0, so this value becomes 0. So 0 plus y is equal to 9. So y will be equal to 9. And you can say the solution as 0, 9. Solution as 0, 9. Correct? If I take x equal to 1, I got y equal to 5. If you take x equal to 0, we'll get y equal to 9. Take x equal to minus 1, you'll get some other value. X equal to 2, you will get one more value. X equal to 1.5, x equal to 0.5, x equal to 0.1. Lot of solutions, not just one or two, we have infinite solutions. Right, we have infinite solutions. Okay, let's move ahead. Let's move ahead for the next question. Given x equal to 3 and y equal to 2 is a solution of the equation 5x minus 7y is equal to k. So here the point is not to find the solution. The point is not to find the solution, but given x and y values, using those x and y values, we need to find the value of k. We need to find the value of k. Once again, carefully listen here. X and y, 3 and 2 is a solution. When I say solution, that means it should satisfy the equations. Here only one equation is there, so those two values of x and y should satisfy this equation 5x minus 7y is equal to k. Satisfy means you just need to substitute that value of x and y in the given equation. That is the meaning of solution. So 5 times of x, 5 times of 3 minus 7 times of y, 7 times of 2 is equal to k. 5 times of 3, how much is that? 5 into 3, 15. 15 minus 7 2s are 14 is equal to k. So k will be 15 minus 14, which is 1. The value of k is 15 minus 14, which is equal to 1. Alright. Once again, carefully see here. X equal to 3 and y equal to 2 is a solution of the equation. Solution means these two values should satisfy the equation. These two values should satisfy the equation 5x minus 7y is equal to k. Right? Okay. So from there we'll get the value of k equal to 1. And here you may see that we have only one value of k. We don't have several values of k satisfying, correct? Why? Because x is a linear, y is a linear. You're substituting here, you'll get only one value for k. K is a linear. Linear means k power 1. We don't have k square. We don't have k cube. You know what is square and cube, correct? As we have linear terms, we have only one value of k. If you have k square or if you have k cube, then your number of solutions will be different. Your number of solutions will definitely be different, not one. Right? So let us move for one more question. Okay, given x equal to 2k plus 1 and y equal to k is the solution of the equation 5x plus 3y minus 7 equal to 0. Again, x and y are given, but here what is the difference between the before question and this question? In the before question, directly x and y values are given. X equal to this much, y equal to this much. But here x and y are again given in terms of k. It's a solution of the equation 5x plus 3y minus 7 equal to 0. Find the value of k. So we don't have k in the equation, but you have in the values of x and y. So process same, just substitute and find the value of k. So 5 into x, what is x? 2k plus 1 plus 3 times of y, k, minus 7 equal to 0. 5 times of 2k plus 1 plus 3k minus 7 is equal to 0, correct? So 5 into 2 is 10k plus 5 into 1 is 5. 5 into 1 is 5 plus 3 into k is 3k minus 7 is equal to 0. 3k minus 7 is equal to 0, correct? So 10 plus 3 is 13k plus 5 minus 7. 5 minus 7 is a minus 2 equal to 0. A minus 2 is equal to 0. So we say that 13k is equal to 2 and k is equal to 2 by 13. K is equal to 2 by 13. Once again, please cross check that. 5 into 2k plus 1 plus 3k minus 7 is equal to 0. 5 to is 10k plus 5 into 5, 3k minus 7 is equal to 0. 10 plus 3 is 13k, 5 minus 7 is minus 2. So from there you can get k is equal to 2 by 13. K is equal to 2 by 13, correct? Okay, so one more question for your practice. I'm not going to say the solution for you. Okay, the next question is x equal 2 minus 2 and y is equal to plus t. 2 minus t and 2 plus t. Be careful, don't get confused. If you consider x here and y here, again you will get a different answer. Okay, so x and y are given as a solution of the equation 3x minus 2y plus 6 is equal to 0. That means x and y you need to substitute here and that should be satisfied. Okay, then find the value of t. Okay, substitute and find the value of t, you will get the answer value of t. But still there is a question. Also find 3 more solutions. Find 3 more, not just one. Find 3 more solutions of the resultant equation. So once you get the value of t, okay, so this is the equation, right? 3x minus 2y plus 6 equal to 0. You will substitute, you will get the value of x and y. But that is not the answer. You still need more and more values to say that that is a solution of the equation. Understand? Okay, so that is how you try to solve this one. Just substitute the values of x and y in the given equation and try to find the unknown value. Unknown value maybe sometimes it is placed with x and y, or sometimes it will be with the equation. So based on that you can try to solve the equation, correct? So yeah, so that's all for today's class, and in the next class we'll continue with how to solve linear equations. But when we're solving, we don't consider one equation, we consider 2 equations at a time. We consider 2 equations at a time and we try to solve in different methods, right? So thank you so much. Stay tuned to get the next lecture. Thank you.
Yeah. Hello everyone. So today we'll be discussing about rest and motion. Okay. So my name is Shashin Reddy. I'm a graduate from IIT NEET. So let's start the class. So when we talk about rest, what do we actually mean when we say that a body or a particular body is at rest? Look at this, for example. Here we have a few books, 4 books exactly, 4 books placed on a table. Generally, when we look at them, we say that these books are at rest. So what do we mean? When we say something is at rest, for us, its position is not changing. It is not moving. Right? Its position is not changing. So that's what we say. That's what we call a body at rest. Body is said to be at rest when its position with respect to its surroundings does not change. See, look at this. Does not change. What does not change? Position with respect to surroundings does not change with time. Simple, right? Or else if the position changes, I mean, see, I've been walking. So my position is continuously changing when I walk. Right? Even very slowly, even very small, but my position is changing when I am walking. Yes. So am I at rest? No, not at rest, because my position is changing. But look at the screen. Is the screen moving? No. The screen is at rest. Yes or no? This complete screen is at rest because it is not moving. That's what we mean when we talk about rest and motion. Clear? Okay, just a minute. So when we want, what does motion mean then? It's very simple. Its position changes with time. So whenever a body's position changes with time, we say that that object is in motion. For example, you can see a tiger. That's a tiger, right? So a tiger running, and the position of the tiger is changing in the animation. The tiger is in motion. Tiger is in what? Tiger is in motion. Simple? Yes? Okay. Now, there are some important properties, always understand. Whenever you look at something and we say something is at rest or something is in motion, that is relative. What does that mean? I'll explain. Look at this. Here, look at this camera. When we look at this animation, we feel that this particular side is at rest. This side, the left side. And the trees are appearing to go back. Now, does that actually happen? And where have you noticed this? In everyday life, whenever we are traveling in a car or any vehicle, we notice this. Yes or no? So this is a car. You can clearly see that car appears to be at rest. The trees are going back. The trees are traveling. Trees are moving. But does that happen? No. Trees are at rest, but we or the car will be in motion. Yes or no? So whether the tree is at rest or the tree is in motion depends on person to person. So on which person? I'll take a simple example. Let's say this is a road. And let's say there is a car. And inside the car, let's say there is a person. I'll call that person as A. Now outside the road, just besides the road, there's another person B. Now there is a tree here. There's a tree. So here for A, or according to A is in the car. And let's say car is going to front, car is going towards the right. So when the car is going towards right, the person A will also be going towards right. So for the person A, tree will be going back. Tree will appear to move back. Yes or no? Tree will appear to move back. But what about for person B? For person B is just standing. Person B is just at rest. He or she is at rest. That's it. They're not doing anything. They're just standing. So for this person B, for B, tree is at rest. You see that here the same tree is moving back for A but is at rest for B. The same tree. Magic? No. It just means that motion is relative. What does relative mean? Motion depends on who is watching, who is observing. In the first case, when I say for A is observing. When I say for B, B is observing. So what is different here? Observers are different. The one who is seeing is different. The one who is watching is different. Clear? Yes? So, another example. Similar one. You can think of it as a train or a metro, right? A train. So, train is traveling and you can see buildings are moving back. See? See here. The buildings are moving back. Do the buildings actually move back? No, they don't. Buildings don't move back. They appear to move back because here, according to this, we are in the train. So for a person in the train, the buildings appear to move back. But for a person standing outside on the platform of the train, buildings will be at rest. So again, motion is what? Relative. It depends on who is watching, who is observing. Depends on the observer. Clear? Understood? So an object can be in motion relative to one set of objects, one type of objects, one case of observers, while at rest relative to some other set of objects. It depends on which object is observing. Clear? Okay. Now for example, the best example is this, one of the simple examples. Now look at this girl here. This girl is happily sitting on a sofa. Happily sitting on a sofa. Now if you ask the room or the sofa, if you ask the sofa, what? Sofa, is the girl at rest or is the girl moving? What are you asking sofa? You're asking sofa, is the girl at rest or in motion? What will the sofa say? The sofa will say, the girl is just sitting happily. She is just at rest. Sofa will say that the girl is at rest. But if you ask the same question to sun, to the sun, exactly, the sun. What does the sun say? The sun will say, the girl is moving along the earth. And what is earth doing? Earth is revolving around the sun. So when you ask the sun, is the girl at rest? The sun will say, no, the girl is not at rest. The girl is what? The girl is revolving around me, around the sun. Understood? Simple example. For the sofa, the girl is at rest, but for the sun, the girl is moving along the earth, revolving around the sun. Understood? Right? So again, a simple case. Depends on whether you are at rest or not. Depends on the observer. Okay? Understood? Very simple example. Clear? Okay. So that's it, everyone. That's it for today's class. See, rest, we learned about rest and motion, and that rest and motion are relative. Very simple. Okay? Thank you.